Okay, so suppose we want to draw a graph regarding this example. Then on x-axis here 1, then 2, then 3, 4, 5, and so on. And here final result of these f of n, that is here suppose from 2, then 4, then 6, then 8, 10, 12, and so on. For 1, value is 6. Okay. For 2, value is 9. Then for 3, value is 12. Okay. So function starts from here. For suppose n is equal to 0, then it gives 3. If n is equal to 0, it gives 3. So starts from here. This is the ratio, or this is line for the f of n and suppose we draw the line for g of n, that is this 4n. 4n is g of n. Then same for 0, it will be 0. Okay. For 1, it is 4. For 2, it is 8. For 3, it is 12. Here for 0, f of n 3. Then for 1, it is 6. Then for 2, 9. Then for 3, 12. So this is line for f of n, and for g of n 0 for 0. Then for 1, it is 4. For 2, it is 8. For 3, it is 12. For 4, it is 16. Okay. This line for g of n, and this point or this crossing point is your big OH point, that is you can write equation f of n is equal to order of n such that f of n is equal to some constant into g of n. Are you getting? हेलो,
Yes, sir.
समझ ले?
Yes, sir.
Okay, so we move our slides. So big OH notation is used to define the upper bound of the algorithm in terms of time complexity. That is, the big OH notation always indicates the maximum time required for algorithm for all input values. The big OH notation is consider the function f of n as time complexity of algorithm, and g of n is the most significant term. Then it can be denoted as f of n is less than equal to c into g of n, and for all values n is always greater than n0. N0, that means 1, and c is always positive constant, and this is represented as f of n is equal to order of or big OH of g of n. So we have seen the two examples. Out of them, this example we have taken. Suppose here 3n plus 2, f of n is 3n plus 2, and here g of n is equal to suppose 4n. G of n is equal to 4n, then this can be represented as, or g of n is equal to n, it can be represented as f of n as big OH of g of n, and this must satisfy the equation like this, that is f of n is less than equal to c into g of n for all the values, of n, that is c is always greater than 0 and n is always greater than 1. Okay, we have seen the example. Suppose this is a graph drawn for the f of n function. Okay, and this graph drawn for c into g of n function, then this is the a point where these two functions cross each other, that is, this point is known as n0, the point at which these two functions cross to each other is known as their one minute. The point where these two functions or these two lines cross each other, that is the known, it satisfies the equation at that point. Okay, f of n shows p into g of n. It shows the actual growth of that equation or actual growth of that algorithm as per requirement or as per expectation. It will like this, but it gives like this. It gives like this, and that's why it is worst case. See here, initially in less inputs, okay, this is the graphical representation of BOH notation. We'll take more examples on these. Suppose next example is hundred n plus 6 is equal to order of n, such that hundred n plus 6 is less than equal to 101n for all n is equal to or n is greater than equal to. You should have to find this value. Okay, see here, this is f of n. Okay, this is g of n, and this is some constant. This is multiplication of this, and you satisfy this equation. You satisfy this equation. So you should have to find the value of n. One zero one. Then put n is equal to 2. Then 100 into 2 plus 6, that is 206. Then 101 into 2, you will get 202. Then put n is equal to 3 plus 6, okay, 8 here, 9. Then put 4 1 minute. 300 3, then put n is equal to 4. N is equal to 5.
Hello, sir. The 206.
Hello. Hello.
Hello, sir.
हाँ बोला ना.
So तिथं 106 206 306 पाहिजे ना.
हाँ
आता
तेच करेक्शन लक्षात आलं माझ्या. कुठे आहे? एक मिनिट. 206, then 306, then 406, then here, which is equal to 506. Then here put 5. Then if we put 6 plus 6, you will get 606. And if we put here 6, you will get 606. So here for all n is greater than equal to 6. So here C is 6 or greater than 6. Are you getting? समजता है? हॅलो, तुम्हाला समजलंय? समजलं नाही? काहीतरी सांगा. हॅलो,
Yes, sir.
समजलंय?
Yes, sir.
Okay. May I give a new problem? Then you should find the value of n. Okay. I am giving a new problem. Then 10n square plus 4n plus 2 which is less than equal to 11n square. Then find n. N is greater than equal to question mark. Okay. So here put n is equal to suppose 2. So 10 into 2 bracket square plus 4 into 2 plus 2, which is equal to 50. Eleven into 2 square. Then if n is equal to 2, n is equal to 3. Okay, put 5. N is equal to 5. 10 into 5 square plus 4 into 5 plus 2, which is equal to 250, 272, and 5 square, which is equal to 2. 275. Okay, see here 272 when n is equal to 5. 275. Okay, this is for f of n, this is for c into g of n. So we'll check for n is equal to 4. So 10 into 4 square plus 4 into 4 plus 2, which is equal to 160, 176, 178. Okay, then 11 into 4 square, 168. Now 176. So it satisfies the equation at n is greater than 5. N is greater than equal to 5. Are you getting? समझ ले?
Yes, sir.
Okay. What is big OH notation? So big OH notation is used to define the upper bound of an algorithm in terms of time complexity. So that is, it always indicates maximum time required by the algorithm for all input values. Maximum time is required. Okay, it is also known as worst case. For that worst case time complexity for the particular algorithm, if there are two functions f of n for time complexity and g of n is most significant term, these two functions are related to each other such that f of n is less than equal to c into g of n, where c is a positive constant and n is always greater than 1. So this term can be written in BOH form as f of n is equal to big OH into big OH of G of n. Okay, this is in example format. This is in graphical format. This is the graph for the function. Okay, and this is a graph for the big OH. This is the big OH. Okay, this is the expected. The brown color is show for the expected, whereas the blue color line shows the actual or practical. That it will, this blue color indicates that it takes more time for execution, and this is n0 where the equation satisfies, both equations satisfies the point at which both equations satisfies. Okay, then second is big omega notation. Okay, so it is known as lower bound of algorithm in terms of time complexity. That is, the big OH notation always indicates the minimum time required by algorithm, whereas the big O notation indicates that it will take maximum time, but big omega indicates that the minimum time required for by the algorithm for all input. That is, it describes the best case complexity, time complexity of an algorithm. So what is the definition of big omega notation? Consider there are two functions, f of n as time complexity of an algorithm and g of n is most significant term, which indicates that f of n is greater than equal to c into g of n, where c is a constant for any positive constant. So, and n is always greater than 1. And it is denoted, or it can be represented by f of n as omega of g of n, such that f of n is equal to omega of g of n. We'll take examples on these. First example, Cn plus 2 always greater than Cn. Okay, we should find the value of n for all n is greater than equal to which value? In this case, this is f of n, then this is g of n, this is a constant, okay. Here we should have to find the value of n So put n is equal to 1. So 3 into n plus 2, that is 3 into 1 plus 2, it is 5, and 3 into 1, it is 3. For 2, 3 into 2 plus 2, which is equal to 8, and 3 into 2, which is equal to 6. So for all values greater than equal to 1, okay, for all values it satisfies the equation. Okay, समझ लें? हेलो हेलो, समझ लें कहाँ?
Yes, sir.
I will take a second example. So 100n plus 6 is always greater than equal to 100n. Then find the value of n for n is greater than equal to question mark. Okay, find out the value of n. Hello.
It's 101
1. Okay, so every time, see, every time here f of n is always greater than equal to c into g of n in case of big omega. Okay, in case of big omega, but in case of big O, f of n is always less than equal to c into g of n. Are you getting a difference between these? So keep in mind, for finding upper bound, then f of n is less than g of n. Or worst case, if you see f of n is always less than c into g of n, then it is a worst case and it is upper bound. Whereas f of n is always greater than c into g of n, then this is the best case and this is lower bound. Okay, are you getting? समझ है? Hello. समजत नसेल तर नाही म्हणून सांगा. हॅलो. I am waiting for your response.
Yes, sir.
Yes, sir.
Okay. Okay. See, there are two functions, f of n and g of n, such that f of n is equal to cn plus 2 and g of n is equal to n, such that c of 3n plus 2 is greater than equal to c into n. If we put c is equal to 5, any positive constant, c is equal to 5 and n is equal to 1, then what is the value of these? N is equal to 1 and c is equal to 5. Then this satisfies the equation. Five is greater than equal to 5. If we put c is equal to 2 and n is equal to 3, then it also satisfies. Okay. That is, if we want to represent f of 1 as omega of g of n, then must satisfies the equation, that is f of n is always greater than equal to c into g of n for all values of c, positive values of c, and for all values greater than equal to, for values of n greater than equal to 1. Okay, this is the example. This is the graphical representation. See, if we plot a graph, this is f of n. Before that, we'll see the graphical representation of the example. suppose f of n is equal to 3n plus 2 and g of n is equal to, suppose, n, such that f of n is greater than equal to c into g of n. So 3n plus 2 is always greater than equal to, suppose c is equal to 5 or c into n, and put, suppose c is equal to 1, okay, c is equal to 2, n is equal to, suppose, 3, then it will give the values 3 into 3 plus 2 is equal to 11, and 2 into 3 it will give 6. Then put c is equal to 3, n is equal to 3, then it gives 3 into 3 plus 2 is equal to 11, and 3 into here 3 into 3, which is gives 9. Then c is equal to, suppose, 4 and n is equal to 3, then we'll get 3 into 3 plus 2 is equal to 11, and 3 into 4, which gives 12. There is mismatch. So if we draw the value, draw the graph with the help of these values, here time, here input n, so this line shows for f of n, and this line shows c into g of n. So at this point, these two lines cross to each other, and this point, at this point, satisfies the particular equation, that is n0. Okay. This is the graphical representation of f of n with respect to time and input n. This is the brown color line for the c into g of n, and there is a point where the both lines cross each other and satisfies that particular equation. This is the brown color shows the actual or expected time complexity, whereas the f of n, this blue color line, shows the practical time complexity. So it takes less time as compared to f of n takes less time as compared to c into g of n. That's why it is known as best complexity or best complexity or best time complexity. Then third is theta notation. So theta notation is used to denote average bound of an algorithm in terms of time complexity. We have seen that the big OH notation is used to denote worst or upper bound of an algorithm in terms of time complexity. The omega notation is used to denote the lower bound of an algorithm in terms of time complexity, and the theta notation is used to denote the average bound of an algorithm in terms of the time complexity. The big theta notation always indicates the average time required for the execution of the algorithm for all input values. Big theta notation always indicates the average time required by the algorithm for all input values. Big OH notation, it indicates worst time or it requires maximum time for execution of that algorithm. Then big omega notation always indicates the minimum time required for the execution of that algorithm. But the big theta notation describes average case of an algorithm time complexity, whereas big OH notation for best case complexity, then big omega notation used for big OH for worst case complexity, big omega is used for best case complexity, and whereas the theta notation is used to describe average case complexity of the algorithm. It can be defined as follows. Consider there are two functions, f of n as time complexity of an algorithm and g of n is the most significant term. So there are two constants in big OH and big omega. There was single constant. There are single constants. In big OH they are greater, in big theta they are less, and here one is greater and one is less. Here two constants are used, one is less than f of n and other is greater than f of n. That is, f of n lies between these two constants. So c of n into g of n is always less than equal to f of n, and c2 into g of n is always greater than f of n. So for all values of n, all positive values of c1 and c2, this equation must satisfy, then it can be denoted as f of n is equal to theta of g of n, and the graphical representation C. The blue line for C2 into g of n, it shows the upper bound. C1 into g of n, it shows the lower bound, whereas the f of n, the brown color line, it shows the average level. Okay, are you getting? समझलं समझलं नहीं है? हेलो, हॅलो, समजलं नसेल तर नाही म्हणून सांगा. आवाज ऐकायला येतोय ना? हॅलो,
Yes, sir. Yes.
ओके, समजलं नसेल तर नाही म्हणून सांगा, चालेल. कारण गप बसल्यानंतर कसं कळणार तुम्हाला समजलंय किंवा समजलंय? हाऊ कॅन आय अंडरस्टँड? समज नसेल तर बिंदास नाही समजलं सांगा, परत शिकवलं जाईल. जर तुम्ही गप्प बसणार असेल तर मी अझम्पशन काय करायचं तुम्ही सांगा. समजलंय असं समजायचं की समजलं नाही असं समजायचं? हॅलो, जर तुम्ही उत्तर देणार नसेल तर पॉझिटिव्ह म्हणजे तुम्हाला समजलंय असं समजून पुढे जायला काही हरकत नसावी. ओके, टेक एक्झाम्पल ऑन दिस. The given example as like this, 3n plus 2 which is equal to theta of n such that three n plus 2 is greater than equal to 3n and 3n plus 2 less than equal to 4n. Find the values of n or find n. So we'll see this equation first. So for this equation, put n is equal to 1, then 3n plus 2, which is equal to, that is 3 into 1 plus 2, which is equal to 5, 3 into 1, which is equal to 3, then n is equal to 2, 3 into 2 plus 2, which is equal to 8, 3 into 2, which is equal to 6, n is equal to 3, so 3 into 2, 3 into 3 plus 2, which is equal to 11, and 3 into 3, which is equal to 9. So it shows always at n is greater than equal to 1. Okay, we'll see this side. Put n is equal to 1 for this equation. N is equal to 1. Then 3 into n plus 2, that is 3 into 1 plus 2, which is equal to 5. Then 4 into 1, which is equal to 4. Then n is equal to 2. That is 3 into 2 plus 2, that is 8, and 4 into 2, that is 8. So this equation satisfies always n is greater than equal to 2. Take common value of n. Here always n is always greater than 1. Here n is always greater than 2. So for both equation satisfies for all the values of greater than equal to 2. Are you getting? समझता है?
Yes, sir.
Okay. In previous situation or big omega or big OH notation, there are only one condition. You should have to check, or you should have to find the value of n by checking only one condition, but here you should have to check both cases, either less than equal to and greater than equal to, and find out the values of both cases and take the common values of n. So this equation always satisfies for n is greater than equal to 2. Okay. We'll take a second example. Okay. So in big theta notation, the given conditions are C1 into G of n is less than equal to f of n is less than equal to C2 into G of n. So we have solved this example. Then performance measurement. So for performance measurement, there is a table. In that table, there are some notations and their mathematical names. So order of 1, that is constant time. If here any other constant, then it is constant time. Order of log of n or order of log n, it is logarithmic time. Order of n, that is linear time. Then order of n log n, linear logarithmic time. Order of n for linear time, order of log n for logarithmic time, combination of both. So order of linear logarithmic time. Order of n square is quadratic time. Order of n cube, that is cubic time. Order of 2 raised to n. 2 raised to n, it is exponential time. And n factorial, it is factorial time. So order of 1 is always greater than log n. Sorry, order of 1 is always less than order of log n. Then order of log n is always less than order of n. Order of n is always less than order of n log n. Order of n log n is always less than order of n square. Order of n square is always less than order of n cube. And order of n cube is always less than order of n factorial. These 6 equations or these 6 statements can be combined as order of 1 is less than order of log n is less than order of n is less than order of n log n is less than order of n square is less than order of n cube is less than order of n factorial. So suppose n is equal to, we have taken some values, n is equal to 2, 3, 4, 5, 6 up to 12. We have taken these values and we have find out the values. Order of 1, it is 1. Order of log n, for 2 we have find out these values. 0.3. Order of n, it is 2. Order of n log n, that is multiplication of these two, that is 0.6. Order of n square, that is 2 square. 4. Order of n cube, 8. And 2 raised to n. Okay, we'll see. Suppose we draw a table like this. N then log n, then n log n, then n square, n cube, and 2 raised to n. If we put value of n is 1, log n is 0, n log n is here 0, n square is 1, n cube is 1, then 2 raised to 1 is 2. Then suppose if we take value of n is suppose 2, then log n is here, consider 1, then multiplication of these two, n log n here 2, n square, that is 2 square 4, then 2 cube 8, and then 2 raised to 2, that is 4. Then suppose n is equal to 3, log n is equal to suppose 4. Suppose n is equal to 4, then log n is equal to suppose 2, multiplication of these two 8, then square of this 16, then cube 64, then 2 raised to 4, that is 16. Then here suppose 8, then log n is 3, n log n is 24, then n square, that is 64, n cube 5 1 2, then 2 raised to n, that is 2 raised to 8, 5 1 2 raised to 8, that is 256. Then suppose here 16, n is equal to 16, then log n is equal to 4, here n log n 64, then n square, that is 256, n cube, that is 4096, and 2 raised to 16, that is 65,536. Okay, these values of n is taken from here. 2 raised to 0 is equal to 1, 2 raised to 1 is equal to 1, 2 raised to 2 is equal to 4, 2 raised to 3 is equal to 8, 2 raised to 4 is equal to 16. Likewise this here 2. Okay, if we draw the graph of these with n and the time, that is f of n and the time, we receive the graph look like these. Here n, okay, so here 2, 4, 8, 2, 4, 6, 8, 10, 12, 14, 16, okay, and here the values will take 10, 20, 30, or instead of this we'll take 20, here 20, then 40, 60, 80, 100, 120, then 140, okay. So we'll plot graph for first log n. For these values, first we plot a graph. So for n is equal to 1, log n shows 0, that is here. N is equal to 2, value is 1 here. N is equal to 3, then it shows 8. N is equal to 4, it shows 16. That is graph of these goes like this. This is log n. Then n log n, we draw graph for n log n. For 1, it is 0, same point. For 2, it is 2, okay. For 4, it is 8. Then for 8, it is a 24. Then for 16, it is 64. That is graph goes like this. This is for n log n. Then for n square, 1 as it is. Then for 2, it is 4. Then 4, 16. Then 8, 64. Then for 16, 256. That is here n square. Then next graph for n cube. And then here 2 raised to n. Okay. Are you getting? Hello? Are you getting? Similarly, see the graphs. Okay. We'll stop here. If you have any query, ask. I will revise once again. Okay. We stop here.
Okay.